Have you ever looked closely at a world map and noticed something peculiar? The coastlines of South America and Africa fit together like pieces of a giant jigsaw puzzle. It's as if they were once united, only to drift apart over millions of years. This observation intrigued Alfred Wegener, a German scientist. Wegener proposed that continents were once joined in a single landmass. This idea, known as continental drift, challenged scientific beliefs. Initially met with skepticism, Wegener gathered evidence to support his claims. He noticed similarities in rock formations and mountain ranges across continents. Wegener's theory eventually gained acceptance, reshaping our understanding of Earth's history. Alfred Wegener, driven by his observations, proposed the theory of continental drift in 1912. He suggested that all continents were once a supercontinent called Pangia. Wegner believed Pangia broke apart, leading to the current continents. His theory faced resistance and skepticism. Despite this, Wegener defended his theory, gathering evidence. His belief in continental drift revolutionized our understanding of Earth's dynamics. One of the most compelling pieces of evidence supporting continental drift came from the study of fossils. Wegener noticed that identical fossil species were found on continents now separated by vast oceans. This observation was difficult to explain unless the continents were once connected. For instance, fossils of the Mesosaurus, a freshwater reptile, were found in both South America and Africa. It was highly unlikely that this reptile could have swum across the vast Atlantic Ocean. The presence of identical fossils on these distant continents strongly suggested that they were once joined. In addition to fossil evidence, Wegener also pointed to the matching geological formations on different continents. He observed that mountain ranges in South America and Africa lined up perfectly when the continents were brought together. This alignment of geological features further supported the idea of continental drift. The evidence from fossils and geological formations provided strong support for Wegener's theory. These clues from the past suggested that the continents were not always in their present positions and that they had indeed moved over millions of years. Section 4. Pangia, the supercontinent. Imagine a world where all the continents were joined together, forming a single massive landmass. This was Pangia, the supercontinent that existed millions of years ago. Life on Pangia was vastly different from what we know today. Pangia had a single vast ocean surrounding it known as Panthalissa. The climate on Pangia was likely much hotter and drier than the present-day climate. The interior of the supercontinent was probably arid, with vast deserts stretching across its expanse. The breakup of Pangia was a slow and gradual process that occurred over millions of years. The exact mechanism that drove this breakup is still a subject of ongoing scientific research. However, it is believed that the movement of Earth's tectonic plates played a significant role. As Pangia broke apart, the continents slowly drifted to their current positions. This process of continental drift continues to this day, although at an incredibly slow pace. The continents move at a rate of a few centimeters per year, about the same rate as your fingernails grow. Section 5. From Skepticism to Acceptance. Despite the compelling evidence presented by Wegener, his theory of continental drift was initially met with skepticism and even ridicule from the scientific community. Many scientists found it difficult to accept the idea of continents ploughing through the ocean floor. One of the main reasons for the skepticism was the lack of a plausible mechanism to explain how continents could move. Wegener could not adequately explain the forces that would be strong enough to move such massive land masses. However, the tide began to turn in the 1960s with the development of the theory of plate tectonics. This theory provided the missing mechanism that Wegener's theory lacked. Plate tectonics explained that the Earth's outer layer, or lithosphere, is broken into several large plates that float on the semi-fluid asthenosphere beneath. The theory of plate tectonics revolutionized the field of geology. It provided a unifying framework for understanding a wide range of geological phenomena, including earthquakes, volcanic eruptions, and mountain building. Wegener's once controversial theory of continental drift finally gained widespread acceptance as a fundamental principle in earth sciences.